Alrighty, so for example, 8, looks like we have a quadratic on the bottom, and it's also repeating. So since it's repeating, quadratic, that means we're going to have case 4. So that's where we're going to do variable x plus variable. And then for the repeatings, we start at the first power, and then we just go all the way up until how many ever powers we have. So we'll have the first power. We'll do the first one raised to the first power, and then the second one raised to the second power, and then we'll do variable x plus variable, variable x plus variable, because they're both quadratic, okay? And then we do the same stuff that we've been doing. We write this stuff on the top, and then we write this stuff on the top, and then we multiply it by what's missing. We want it to look like this. This one's missing 1x squared plus 1, so we multiply it by it. This one over here is missing nothing. It already has the square, or the x squared plus 1 squared, so we just write it, okay? Here we can do some foiling, and then we'll end up with this stuff over here, and then we can combine our stuff. The highest power over here is a 3, so I added the extra 0x cubed here, okay? So I did the purple ones first, and I left off the x cubes, and that leaves us with 0 is equal to a. Perfect. Now I do my squareds next, leave off the squareds, and b is equal to 1. Perfect. We do our x's next. That leaves us with 1 equals a plus c, and then we already know that a is 0 from our purple, so we have c is 1, and then we do our black for just our numbers, and we have 1 is equal to b plus d, and we already know that b is 1 from the green, so we plug that in and we get d is 0. Okay, so we go back up to this right hand side and we plug in our numbers that we just found. Okay, I went ahead and split them up. So for this first one, the a just goes away and we're left with b, so we have the 1 on the top. And then for the second one, the c is just 1x, that's why there's an x there, and then the d goes away, okay? And then I put that stuff on the bottom, okay? All right, so we go back to our chart on 81. This is the same one we used on that previous problem on example 6. Right here. So essentially our a again is 1, and our, let me see, so I'm gonna write that. So a is equal to 1, and our u in this case is x. So if we rewrite this as this other side, that's going to give us 1 over 1, which just goes away, tangent inverse, and then u is x, and then that's it, okay? So that's actually way simpler than expected. We actually had another one. I think it was in like section 7 point, I don't want to say what section, I want to say 7.1. I could be wrong, but yeah, the chart on page 81 is like the more complicated chart, because if a is 1, you don't actually need those fractions there. So I know that can be a little confusing, but if you look back through your notes, there's a simpler version of this where it already assumes that your a is 1, right? So it does like x squared plus 1 on the bottom and then rewrites it as this, okay? But it should be somewhere in chapter 7 if I'm not mistaken, so you guys can look that up if you want to, or just continue to use this chart, okay? Yeah, so perfect, right, because our derivative of u here would just be 1, and there's a 1 on the top. Perfect. Okay, moving right along. Here we have a squared on the bottom, which means we need to do u substitution. So if we we're going to let the u be the stuff on the inside, which is x squared plus 1. If we take the derivative of that, we get 2x dx. So this green stuff right here is actually not there, right? So right now, when we plug in, sorry, I'm just trying to explain to you guys where this is coming from. All right, so first I plugged in this u from x squared plus 1. So now instead of this, it's going to be u squared, okay? And now we have left over is this, okay? We need to change it from dx to du, right? So I've underlined this circle part is this underlined part, but it's missing a 2 to be able to change it to du. So if it's missing the 2 to be able to change this whole thing to du, we have to divide by a half, okay, to cancel out the 2. So now we can now rewrite all of this as du, okay, and that's where that's coming from. Because we have that 2 on the bottom, we can bring it to the top by making it negative, and then to take the integral, we add 1, which gives us -1, then we divide by that -1, which changes the sign of this, okay? And then we originally were asked to solve for a problem with respect to x, so we go and plug that back in. Our u was originally x squared plus 1, so we plug that in. You can move it to the bottom if you want because it looks prettier, and then don't forget to tack on the c because we're not evaluating it from anything.